Thank you. Yeah, basically I significantly shortened the talk. This is the talk I really want to give. And it's maybe you know about the EU wallet or some wallets. That's not part of the talk. What I really want to talk about is anonymous credentials, and I hope that after the talk you know what I mean when I say anonymous credentials. Okay, so let's start. 3 disclaimers before. I did used to be paid by Cloudflare. This is just like work I did with them, mostly while I worked there last summer. I'm currently being paid by the Technical University of Graz, and this is mostly work that is happening at the IETF Privacy Pass working group. It's just some housekeeping, so you know kind of who pays my bills. Okay, so let's talk about what we actually talk about when we say something like a system. And if you maybe took an introductory networking class, this is probably what you have seen. We have a few clients and they want to talk to a server. But because we are not in 1960 anymore, it's usually something that, depending on your geolocation and a bunch of other things, you may be talking to a different server than your colleague who is sitting on the other side of the planet. And in this model, we actually then have servers, and they serve you data if they want to. But if your request looks a bit too strange, maybe you actually will not get served, which is generally something that servers can make as a decision. They say your request looks malformed, I do not want to talk to you. But then the problem is this is also not how the internet works, because we do not have point-to-point connections. What we do have is that very often we have some parties in the middle and some path. And this could be a proxy. This could also be, which was mostly the motivation behind this work, actually, that this is not a client, but that this is an AI agent that you're talking to and that is making requests on behalf of the user, and maybe not even the request coming from a user, but from an AI agent. And previously, this used to be some scrapers or whatever, but now with the rise of systems like OpenClaw, this is actually becoming very, very important. Maybe I told my AI agent, book me a flight to Taiwan, next week, make it cheap and make it so I can reach it nicely from Ljubljana. Then there's actual money involved, and maybe I don't want to necessarily block all of the requests that come from my agentic origin, because this is tied to money. But maybe I want to block the request that says, buy me 700 tickets to Taiwan, because this doesn't look like a very legitimate query. I may not be able to necessarily tell them apart, but I cannot block all of the requests coming out of the Windows server. So, what can I do? In general, I will never have a 100% success rate, but what I can do is I can try to limit the amount of times that I actually talk to a server. And this is generally called rate limiting. So, and this is RFC 9576, which is IETF terminology for privacy pass, and this is just the general architecture. We have 4 parties here. I know this is a big diagram, but we're going to go through it step by step. So what I previously called a server, we usually call an origin, because if you think about it abstractly, everything is kind of a server. But the server has some data that I would like to access. And as the client, I say, oh, dear server, please give me, I don't know, the static block I would like to read. And the server says, I don't like your request. This is very suspicious. Who on earth would ever read this block? First, actually prove to me that this is legitimate by giving me a token. And then the client has to perform some attestation. What exactly this is, I don't know. I'm a cryptographer. I'm not an attestation person. But this could be something like hardware. This could be requiring me to log into an account. This could require me to click a box that says I am not a robot. In any case, I have done whatever the site wanted from me successfully. So they have successfully attested me. And then the issuer is giving me a token, and then I can use the token to actually access the static web page. And because this has taken a very long time, I don't just get 1 token, but I get a stack of tokens, like 20 or whatever, however many the issuer decides to give me. And note that this is not per request, because that would be really, really expensive and annoying, and bandwidth is expensive, and I just made the request for a single static page to be involved with like 2 additional parties and 2 additional round trips. So this is generally happening per session. And then I have my tokens, and at some point they will be invalidated. And that is all very nice. And that is basically what happens when you click I'm not a robot. You get a bunch of tokens, and you can just silently use them. And this is very nice. OK, the talk is not over. I still have 20 minutes. So what do we actually require of these tokens? Let's see. So we have two requirements. First of all, we want the tokens to be unlinkable. That means we want to, and in fact we have a relatively strong privacy requirement that we want the tokens to be unconditionally unlinkable. This means that if I have two token redemptions, it doesn't matter whether they are at the same origin or at different origins, we cannot link them together. I cannot reason whether they were from the same client or from a different client. And this is because we use blind issuance. We don't use XOR, but I have been told that not to assume that you all know finite field multiplication, which I think after Andrash's talk you will probably do. But let's assume I see this token that has been issued blindly, and I blindly issued the token ABC. But I do not know the unblinding value. So if the unblinding value would have been 1111, then it would, and I used XOR for blinding, which is like in this case a one-time pad, this would decrypt to bad C, but if I actually blinded it with OX7022, I would get some coffee out of it, which is very nice. But in general, I do not know. And the reason this is unlinkable is that for every value that is blinded, I can find a corresponding unblinding value just by looking for it, because in general, in a finite field or in XOR, I can always decrypt from one value to the other. I just need to find the correct operation. So this holds unconditionally, so even if I break the underlying crypto system, I am still not able to link the tokens. And this is very important, and people in the industry care a lot about this for post-quantum reasons that I'm happy to discuss in the break. And the second thing we want to have is that the token is not forgeable. So in general, we use something called a cryptographic one more assumption. If you had a cryptography class already, this is what we generally have as an assumption in signature schemes. It means when I give you a stack of tokens, no matter how large, that you cannot forge another token from this very, very large stack of tokens. This is basically, if it were a CTF challenge, the challenge would be to maybe forge another token. This is a computational assumption. That means if you break the underlying cryptography, you can forge another token. There are some reasons for this, but basically, we cannot have perfect unlinkability and perfect unforgeability. This is a cryptographic baseline result. In the case of privacy pass, the decision was made that it would be unlinkable. That's also the easier case. OK, so we have our private tokens. I can redeem them unlinkably at different origins after I have performed some attestation, and everyone should be very happy. And that is still not the end of the talk. Because there is a lot of limitations that we would actually like to address, and a lot of them have to do with AI, but some of them also have to do with the fact that we just can do really nice things with cryptography, and I think we should also do them. And the first limitation is that if I give you a stack of unlinkable tokens, and you keep sending me requests that I do not like, I don't have a way to stop you. So you keep sending me requests, maybe because you're very good at clicking I'm not a robot checkboxes. And I cannot really stop you because I cannot link your question to the question I got previously. So I can either block you outright and not answer any of these queries, or I can let them through, and I have nothing in between. And then I have to wait until an adversarial client runs out of credits, and then I can say, OK, I don't know, maybe I give you fewer tokens because someone has behaved badly. And this is not a very nice model that we want to work with, and it's not very fine-grained. And then there is also the entire problem that AI and Gen AI and scrapers have significantly increased the traffic that we currently see on the internet. And resources are not equal. So for example, I run my own web page, which is a static homepage that exclusively serves you HTML and CSS. You can request it as many times as you would like. I don't care. At some point, it's just going to be cached. The website also has my email address. I do very much care if you send me 7,000 emails. So I would very much like to be able to enforce per resource limits. So for example, that no one is able to send me more than 3 emails a day. If you want to read my blog 7,000 times a day, it's not very interesting. I've not written a lot of things. But go ahead. So I would like to have something that's more fine-grained even when accessing the same resource. And then there's also the problem if we still use privacy paths, and we have these relatively legitimate use cases, and we have these AI agents, and all of this very heightened traffic that maybe I just say, okay, I don't want to perform attestation all the time because it's expensive. So instead of 20 tokens, I give you 1,000. And then you have to issue more and more tokens. And in the current setting, the number of tokens that you issue is the same number as tokens you can actually give in. This is equivalent to going to a fun fair, and then you buy like for 10 rides, and then you get 10 tokens. This works with 10. This doesn't really work with 1,000, because then you need to bring your own bags to have your tokens, and that is not a very fun experience at the fun fair. Because then it's going to look something like this. And we can actually do better, but in order to see how we can actually do better, we need to talk a bit about anonymous credentials. And what anonymous credentials can do is that they can authenticate you without identifying you. So, as I said previously, maybe I have to log in to access a certain resource. And then the only thing the server actually knows is that I have successfully logged in, but does not know as who I am logged in, because I have some identity, or maybe because I have a nice zero-knowledge proof. And I can use this over and over and over again, and the statement does not degrade in privacy, because it's unlinkable. You can say I have logged in, I have logged in, I have logged in. You still do not learn who I have logged in as. And this is just a statement about the property without disclosing it. So what statements could you prove? And the nice thing about zero knowledge is that we can prove a lot. So we can prove an attribute like my nationality. By the time I go back to Austria, maybe I don't want to show my passport and tell the border agent which nationality I have. Maybe I want to be very privacy respecting and just say that I have a European passport. Please let me through. Maybe I want to prove my age to prove that I am allowed to travel borders unaccompanied. And maybe I also want to prove that I'm actually authorized to drive the car that I try to cross the border with. And maybe I want to prove all of these statements in one single statement, so I prove them in conjunction. And then the border agent will hopefully very happily let me pass through with my zero-knowledge proof that I carry in my car. And you're laughing, but this is actually something that is happening right now. So we have the EU wallet, and this is something that we should be able to do kind of next year, which is very nice, because then I have my driver's license on my phone and my passport also on my phone, and I don't need to carry them to Slovenia anymore. I could also prove that I successfully performed the step of attestation. And I cannot just prove that I successfully performed attestation. I can say I successfully performed attestation. An issuer signed actually a statement that I have successfully performed attestation, and I have only shown this statement to a limited number of people beforehand. Very nice. So just like I actually was told to keep this quite high level, but maybe as an intuition on how to prove an age. So let's say I want to give a discount to everyone who is under 16. And then, because numbers that are bigger than 2 confuse me very much, I just decompose this as bits. And I assume that people are under 128. I looked this up. The oldest person to ever have lived is 116, so this is fine. And then I just say, OK, age is a 6-bit number. This is something I can now work with. And then I just have to prove that your age, which is signed by some issuer, actually does not have the 4th, the 5th, or the 6th-bit set. And that is all you have to prove to mean zero knowledge. And this is a very, very simple statement. You can prove it with some check. You can prove it with Peterson commitments. I think we have seen quite a few examples in the previous talk, so I'm not going to go into this too much. And it's a very simple statement to prove. It's very efficient to implement. So this is very nice. So how do we use it for rate limiting? Because maybe we don't want to prove that we're under 16, but we want to prove that we're under 16 showings. And there are 2 protocols that are currently being discussed at IETF, which is kind of like the self-organized standard session of the internet, that give you anonymous credentials that actually rate limit you. The first one is ARC, or anonymous rate limited credentials. And basically you get a signed credential, and then you show a zero knowledge proof that you have only shown this credential a limited number of times to someone else. And we will see how this works in a second. But the nice part about this here is that you get the signed credential, and that's kind of all you get in ARC, with some additional attributes, and the concrete protocol doesn't matter too much. But this has a constant issuance size irrespective of how many times you show it. And that is very nice, because then we do not have to run around with a stack of tokens. It's more like a punch card where people just tick off how many times you have actually shown it to someone. And we can do this in parallel, which is very nice if we are actually operating on the internet. So let's see how this looks. Here I have my client again and my server. And here I have a database, which I need to make sure that you do not spend the same credential twice. So I have my ARC credential. I show it to some resource. The resource asks the database, have you seen this previously? The database says no, but I am going to store it in case I do. And says, OK, do it. And in the same time, in the same time, I have decided, oh, this takes too long. I open another browser tab and I make another request, another resource. And then the ARC is going to say, OK, and then I can talk to the first resource. And in the meantime, the second request arrived, and the database says, oh, this is also fine. We are very happy. However, if I forget to increment my nonce, which was obviously not for malicious reasons, but because I sometimes forget to increment my cantas, then the database will say, no, I actually do not want this. Do not serve this. And then you will just get an error. And this is very nice, because we have solved the problem of the issuance size. So I can do this 1,000, 1,000,000 times, it doesn't matter. And the proof is very efficient. But what I have not done here is because I have these parallel spending capabilities, I still cannot block anyone. And this is kind of an exclusionary result. And the second proposal solves that. So this is anonymous credit tokens. And the idea here is that kind of, I think in Ljubljana you have these bus cards where you put some balance on it, and then you tap your card, and then the balance goes down iteratively. And that is basically what ACT does. So you get issued a credential with a certain balance, and then it decreases every time you actually access a resource. And the nice thing is that this allows stateful policies. So if your request looks kind of fishy, but I maybe still want to serve it just in case, I can say that your request, instead of 1 credit, now costs you 10 credits. You have to ask for a new credential earlier, but I do not refuse you outright. So if you keep doing requests that don't look very legitimate, you can actually have to ask, and then if you always have to ask for new credentials, at some point maybe the answer is no. You have used too much of your budget, chill out a bit. And that is quite nice. A result of this is that we can only sequentially redeem our token. So this will look like this. I have my ACT with a balance of I. I give it to the server. The server once again has to record it, because I obviously don't show either the credential or the balance. I just show a blind version of this. But it's deterministic, so I can do this. This is invalidated. And then I get back, because it was a very legitimate request, to read my own blog once again, because I forgot what I had actually written there. And then the ACT is decremented by 1. And then with my new ICT, I can go again and spend it in another resource, and this is going to take a very long time, and then I am very much back in the 90s. And then if I perform a request that actually looks quite fishy, maybe I get my ACT back with a significantly decreased balance. But I still get served, so I have really nice fine-grained access control. OK. So at this point, I can decide that either I can have parallel requests or I can have a stateful policy. The nice thing is we can actually have the best of both worlds, because we live in the 2020s and we can have expressive protocols. And the answer to this is reverse privacy pass. And what they want to have a lot is that basically the origin can make their own decisions. So my blog can keep surfing, but my mail server at some point will say, no, you have already sent me too many emails. Try again tomorrow. And the idea here is that the client is issued 1 ARC credential with a presentation limit of 1. And instead of a global database, each origin just gets presented this ARC credential. The presentations within themselves are unlinkable. And then, given an ARC credential, you get an ACT credential with a certain balance. What the balance is, it depends. If it was my mail server, you would, for example, get a balance of 3. And then, if you want to send me more emails for whatever reason, you just present the ACT credential. I give you some change. If your email looks suspiciously long, maybe I actually decrease the balance significantly. And if you have already if the email is like over 1 megabyte, maybe actually say, you know what, I don't give you any change. I still don't know who wanted to send me this very long email, but I'm just saying I do not care for it. Come back tomorrow with something that is shorter. Or I give you back your updated credential, and I say, OK, I just issue it to you with your new state and your decreased balance. And this is a lot of use cases. So aside from writing an unnecessarily complicated email server, I don't run my own email server because that is way too difficult. You can use this for web application firewalls and rate limits, which is kind of the reason that Google and Apple and Cloudflare are really interested in this. You can also use this for like streaming budgets and other things where you don't want to perform too much authentication all the time. And there's this entire thing with media over quick, where they want to have like the streaming budgets that are allocated dynamically and anonymously, which is very nice. So for example, if you like to watch romantic comedies, you just have to authenticate, but that you can access all of Netflix, but nobody will ever know that you just watch romantic comedies. Then there's, in general, like anti-fraud applications. You can have more than one abuse counter in ACT. You can have like a conjunction of counters, and they have a very big state, and then depending on the very complicated logic, the origin can decide whether or not to actually serve your request. And then there's also the entire reason why back then we actually cared about it, because we wanted to rate limit AI agents behind origins and kind of give them a budget of how much they can interact with the internet before they get actually rate limited. And I do think that this is actually an application that may be useful, but that is irrelevant because it's an application that's going to be deployed. Which brings me to my conclusion. Whether we like it or not, the internet does not look like in the 60s or in the 90s. The way we interact with the internet is changing. It's changing because of AI. It's changing for a number of reasons. And ARC and ACT and reverse privacy paths are changes that are going to be deployed to the internet. And this is really cool. We should not be sad about the fact that we do not have point-to-point communication anymore. We should be very happy that we have advanced protocols and things like ARC and ACT that are not very complicated. We should look at how to use something like privacy paths, private tokens that are unlinkable, for a lot of use cases. And the design space is really large. I started working on this in summer. I can only speak for myself, but I do say that this is like a relatively open process. It's happening at IETF. It's developed on GitHub. And I get that it's a bit scary to say you have some private tokens and they have a counter depending on your user behavior. But this is the beginning, and if you're scared about it, then maybe participate in the process. Which brings to the next point. Like, I see this very much from a perspective of a very large internet company, because that's where I trained. But if you actually run your own servers and you have problems with that, I would very much like to discuss this in the coffee break, which we're going to have. And if you're a student and you think like privacy and anonymity is cool, I am currently looking for 1 or 2 new students. Basically, I would very much like to discuss this topic a bit further, and also outside of IETF and real-world crypto. If you have any questions also now, I'm very happy to. Thank you very much for your attention and having me.
Do we have any questions for Lena?
So I'm not sure if I understood this correctly, but does ACT require a call to a database on each request? Isn't that like a lot of overhead?
It's basically per session.
But how do the individual requests then get like authenticated or checked, or they don't at all?
I mean, individual requests, and it's kind of like, okay, you've been authenticated, and then like the session is killed, or you get another error. But it is mostly to, like, when you establish the session, so you can sync on TLS handshake, then maybe you also are required to present a token. This is very oblique, and it really depends on like how this is implemented on the origin side. But yeah, this is already happening. So when you see the I'm not a robot checkbox, this is basically you're doing some credential check. But it's privacy paths with tokens instead of an anonymous credential.
Any more questions? Oh, I see 2 more, 3 more. Okay, I'll start from here and go up.
Hi. If I'm understanding correctly, so the ACT can be decremented by however much the server decides, right? Is there a potential vulnerability to like relinking by decrementing by a very specific amount? So if you imagine the like original balance in an ACT would be like huge because computers, big numbers, a server could, I guess, decrement it by a very specific amount that it wouldn't decrement any other request by the same amount. And the next time the person comes along, you now know, okay, so I had one with that number, now one is this much bigger, so it's the same person. Am I underthinking this? Is there fancy math that solves this?
So basically the balance is never purely visible because then it would be clearly linkable. Like if someone comes with a balance of 7 today and with a balance of 6 tomorrow, but I just see the balance is enough. So for example, I may require you to prove that you have a balance that is bigger than 10. Usually I deduct 1. If I don't like your request, it's 10. It's minus 10, and then it's fine. Maybe I deduct a lot of balance from you, then you're likely going to be angry at me. So this is a bit like the entire internet is, it's a bit of capitalism, right? If I charge you too much to access my resource, you're not going to access my resource again, and I'm starting to get a bad reputation. If you do something very fancy, like I only decrement you in primes, that is also not very helpful because this requires me to be very vigilant about your access patterns. And while some fingerprinting can happen, and I'm also relatively certain that early iterations of ACT will have some vulnerability to fingerprinting, I had this as a very long discussion. The alternative that we're currently using is third-party cookies. And third-party cookies are kind of like the worst thing that we could have. And this is very verbatim from a colleague, so I apologize because I was due on last week. Everything is better than third-party cookies, and having some fingerprinting depending on a balance that is actually hidden from me is significantly better than having a third-party cookie.
Okay, one more here.
So, I don't know, maybe it's not directly connected, but let's say that I'm kind of a good guy and I want to make some money. And I will make a relay for these cookies, not cookies, but these tokens. So I will make a payment system where some sketchy guys could buy some tokens from me. So how would that be prevented?
So it's always best effort, right?
Second?
It's always best effort. Even now, I could give you my tokens. It would be annoying to kind of get them out of my browser and give them to someone else, but this is still something I can do. And the prevention mechanism here is that it's usually relatively easy to get a new token for a legitimate user, but then getting it out should just be more expensive than doing something like authentication. And then also maybe it's just like, okay, you give me your 20 tokens, fantastic. Okay, then I have 20 more requests.
Thank you.
And I think there is one more question. Yeah.
Okay, so if these tokens are used per not per request but per session, right? Mm-hmm. How do you protect stuff that are done in the same session? Like one can do a lot in one session. Like yeah.
I mean, during the session, I can always just decide not to talk to you anymore.
Okay.
I should also say I'm a cryptographer. Like, what happens on the server, that's the decision of the server. I can stop talking to you. I can deprioritize you. I can just send you a picture of a giraffe. What are you going to do? It's still the internet. We like to think about protocols in these very complex things, but then I think at any point of a protocol, it's a very good question to ask yourself, can I just send someone an emoji of a giraffe? Is it a valid answer? Maybe not according to spec, but oh, I violated the spec, what are you going to do? Report me to the internet police?
I think this is all the time we have for questions, and if you have any more, please find Lena at the coffee break.
Thank you.
Thank you, Lena.